We're going to talk about now writing quadratic equations and functions. The root of a quadratic equation is the solution, the x values when y is equal to 0. Now, it's also known as a 0, and if it crosses the x-axis, is also known as an x-intercept. And we are going to call these two roots R1 and R2. Now we have a theorem with this that involves the roots. The theorem is 0 is equal to x squared minus the sum of the roots times x plus the product of the roots. And that will create a quadratic equation. Now, to find a quadratic equation with these two roots, we're going to do a few easy steps. First, we're going to sum the roots. So we're going to add the roots. So basically what we're doing is we're going to build an equation with the answers that we're used to getting. The second thing, we're going to multiply the roots. Three, we are going to substitute into the formula or the theorem, and then last we're going to multiply by the LCD so that all of our coefficients are integers. That's our goal. Okay, so our first example, we want to find a quadratic equation with integral coefficients having the roots -3 and 1. So I'm going to come over here and add my roots. So -3 plus 1 is -2. And the product of my roots is -3. So integral coefficients looks like the word integer. That means no fractions. So we're going to substitute in 0 is equal to x squared. Now it's minus the sum of the roots, so we're subtracting a negative. So add 2x and then add the product. And that is our equation. And we're finished. And you could check this by factoring and solving for x and seeing that you do indeed get the roots of -3 and +1. Now let's do one. The next example has two square roots, and we're going to follow the same exact steps. So we're going to add these. Now when you add -√5 and +√5, that's 0. So that's easy. When you multiply them, so -√5 times +√5, the square root 5's just become 5, so it's -5. So when we substitute into our equation, we have our x squared, and the 0, R1 plus R2, makes that middle term go away. And so what we're left with is x squared minus 5. Well, so far we haven't had to multiply by an LCD because we haven't had any fractions, but that's coming up next. Okay, we're going to follow the same steps, and we're going to start by adding these two roots. Now when we add them, we're going to add the -2's, so -4, and then we're going to add the positive square root 5 and the negative square root 5. Well, that just makes a 0. So we don't have to worry with that. So our sum of roots, this is R1 plus R2, is negative 1. Now, if we're going to multiply them, we're going to FOIL the top, but make sure you remember to multiply the denominators. So when we multiply the denominators, we've got 16 right here. And when we FOIL this, this is a conjugate, which means your radical terms, your inside and outside terms, are going to cancel and make a 0. So I'm not going to even bother writing that down. So negative 2 times negative 2, positive 4. And square root 5 and negative square root 5, that's a negative 5. So what we end up with here is a negative 1 over 16. So I see that we're going to have a fraction, so we'll get to multiply. So we're going to have 0 is equal to x squared minus negative 1, so plus, and then 1 times x is just x, and then minus 1 over 16. And so what we want to do here is multiply by 16 to clear the fraction. And we can do this because we're equal to 0. If we weren't equal to 0, you couldn't do this, and you would have to stay with the fraction. And that's our answer, right here. Now if you notice this example, we have a different word involved. We have function involved. And that's different because we're not looking for a quadratic equation. We're not going to have x, 0 is equal. And we're also going to be dealing with this a. We haven't had to deal with an a so far. Well, the question is also different. We're given this information about a maximum value of 8. This is the y vertex, the y coordinate of the vertex right here. So I'm going to write that down like that because we need to find the x. And the way that we find the x is by substituting 8 into our function. Actually, this is f of x, so we're going to set our function equal to that, and we're going to end up solving for it. But this is our, we're going to solve for that in a minute. Actually, let's look at this. ax squared plus bx plus c. So we're going to be finding the x coordinate pretty soon. But we're going to start first by finding the sum of our roots, like this. Add 3 and 10. And then the product of our roots. And so it's 21. Okay, now, the x-intercepts. Remember, parabolas are symmetric. The way you find your x-coordinate of your vertex, because it is symmetric, the x-coordinate of the vertex is right exactly between the two roots. So the way you find this is by averaging the two roots. So that's 5. So we get to fill that blank. Okay, so we're going to start by substituting in the information about the roots here and here. And what's left is the a. Now, our theorem has changed. The theorem is now a times that whole theorem that we just had. So here's the new theorem. The only thing that's changed, well, two things have changed. We're no longer equal to 0. So we're going to have to deal with fractions probably. And we have the entire theorem we had before all multiplied by a. So we're going to have to find a, and we're going to use all of this information. So we're going to substitute R1 plus R2, R1 times R2, and 5 and 8. 5 goes in for x, 8 goes in for f of x. So let's substitute it all in right now. So 8 is equal to a times, so x squared, 25, and then minus 10 times 5, and then plus 21. All that's left is a, which is pretty good. Okay, so we have a And that's 25 minus 50, so that's negative 25. And negative 25 plus 21, that's a negative 4. So A is negative 2. Okay, so the last step, we're going to substitute back in R1 plus R2, R1 times R2, and A, and that gives us our function. So f of x equals negative 2 times x squared minus 10x plus 21. And I'm happy with this answer, but technically, to be technically correct, we should distribute our 2. And this is the equation that we're left with for our function that we want. There we go. Now the last example, we're going to do the same thing, but this time, if you notice, you've already been given the x and y coordinates, and there just happens to be an error. This is actually negative 6 and positive 4, so that was my bad. So we're going to start with adding our roots, and that's negative 2, and we're going to multiply our roots, and that's negative 24. And then we're going to substitute in. So instead of putting the whole vertex in, I'm going to do this a little bit different, add a little extra step. So we've got x squared, and then minus a negative 2, so plus 2x, and then minus 24. Okay, our final answer is going to be exactly this, except we are going to make a substitution for just the a. But to get the a, we need to substitute our vertex in first. So let's do that. And we're going to put in negative 1, so that's squared, and then negative 2, and then minus 24. And this is negative 10 equals negative 25a. And when we divide by negative 25 and simplify this equation, we end up with a is equal to 2/5. Okay, now let's substitute this back in. F of x is equal to 2/5 times x squared plus 2x minus 24. There we go. Okay, to be technically correct, we are going to distribute, and we'll have 2/5 x squared plus 4/5 x minus 48 over 5. And there we go. There's our answer, and that's what you need for this section.